Hey everyone, welcome back to cracking the GRE math subject test. We're still in the differential equations chapter. This is the 12th question. This question isn't too hard, but it does require doing some work. Nothing too tricky here. Our differential equation is here, dy dx. Let's just write that out. Dy dx equals x plus y all over x. This equation is not separable. You can check. You can't separate the dy's and y's and the dx's and x's to different sides of the equal sign. So the next thing we want to do is to check if it's exact. So we're going to write it in the form m, some function m, dx plus n, some function dy equals 0. That's the form of an exact equation under the requirement that the derivative of m with respect to y is equal to the derivative of n with respect to x. So we're going to check that. Let's see, if we cross multiply here, we'll get x plus y. That's going to be our m dx minus x. That's going to be our n dy equals 0. Okay, so this is going to be our m, and this is going to be our n. So now we have to check, does the derivative of m with respect to y equal the derivative of n with respect to x? Well, the derivative of m with respect to y is 1, and the derivative of n with respect to x is -1. So the answer here is no. So in this case, we're going to check if the equation is non-exact, meaning that we can find an integrating factor to turn it into an exact equation. And the way we do that is we take the derivative of m with respect to y minus the derivative of n with respect to x all over n, and we check if that is some function of x. Well, let's see. 1 minus -1, that's 2. And n, that's just -x. So yeah, that is a function of x. And so our integrating factor is going to be e to the integral of this -2 over x, what we called f, with respect to x. Well, the integral of -2 over x is just -2 log x, and from the properties of logarithms, we know that -2 log x is the same thing as log x to the -2, and e to the log of anything is just that thing, so this is going to be x to the -2, or 1 over x squared. So what we're going to do is we're going to take this integrating factor and multiply the whole equation by it. So we'll take this equation and multiply it by 1 over x squared, and that gives us 1 over x plus y over x dx minus 1 over x, and x over x squared is 1 over x, dy equals 0. And we can actually check if this is exact by taking the derivative of our new m with respect to y and a new n with respect to x and seeing if they're equal to each other. Are they? Let's see. The derivative of m with respect to y is going to be 1 over x, and the derivative of n with respect to x is going to be sorry, I made a mistake here. This is supposed to be squared. So this is going to be squared, and then here, this is also going to be 1 over x squared. Okay, so the answer is yes, they are equal to each other, which is good because now we can integrate m with respect to x. What's that going to give us? Well, the integral of 1 over x plus y over x squared dx is going to equal the natural log of x and then minus y over x, right? Because the integral of x to the negative 2 is negative x to the negative 1. So that's going to be the integral of m. And then we can't forget that we have to add here some function, let's call it little g, of y. Now we're going to do the same thing with n. Integrate it with respect to y. What do we get? Negative 1 over x dy. That's going to equal negative y over x plus some function, we'll call it h of x. So now we see that negative y over x appears in both of these integrals, and there is no other function of y in the second integral, so this g of y, we're going to just say that's 0, and then we're going to say that log of x is h of x. So our solution is going to have the form log x minus y over x equals some constant. Okay, well that's not any of the solutions that were offered in the multiple choices, so we're going to have to manipulate this a little bit and write log x equals c plus y over x, and then rewrite that. If we take the exponent of both sides, I'm going to write a little exponent here, then we get x equals some constant. It's not the same constant, but it's some other constant, e to the c, times e to the y over x. Well, that's still not any of the answers, but it's close. If we divide both sides by c, we'll still get some constant, some other constant, times x equals e to the y over x, which is answer A.